what we're going to have here is, you can see that over there. So what we have here is three possibilities of what we were talking about. The first thing is you can deal with sine, right? So if you're looking at trig equations where you're dealing with y equals sine of theta, if you have a sine curve, it starts there, and if you draw a line through it, you'll end up at 2 points. The first point, I can call it x1, and the second point, I can call it 180 minus x1, because the distance from there to there is x1, and the distance from there to there is x1, and that's my 180 degrees, right? So therefore, if I have an answer of x1, I can also call this pi minus x1. So that's my two possibilities for sine. So at the end, theta can equal some angle, let's say x1, and theta can also equal 180 degrees minus x1 if it was in degrees form, right? Because I have a single y value, the exact same y value, but I have two solutions. Okay, so I have two solutions for that y value. If I have y equals cos theta, I also have two solutions. And if I have to keep my solutions positive, and let's say the cos graph continues this way, I can see two solutions immediately over here and over here. This one here, I'll call it x1, and this one here will be the negative of x1 because it's exactly the same distance but in the opposite direction as that one. So theta will be x1, and theta can also be negative x1. But then you have y equals tan. When you have y equals tan and you want to find solutions, you only have one solution. Because if you draw a horizontal line, you'll only have one solution, x1. So theta will simply be whatever value that is. But now we get repeated solutions every time the graph continues, which ends up in what is known as the general solution. So if this graph continues, then we can see that this answer here is going to end up over here, right? And that's going to be basically 360 degrees later. Can you see that? Because it's exactly on the same point on the right hand side of the cycle there. And if you look at the other one is going to be jumping 360 degrees as well to get to the next solution, which means I can add 360 degrees multiplied by a set of integers, where k is an element of the z's, which is your integers. I can also take this solution and do the same, plus 360k. So I can then get what is known as the general solution, which is all the solutions, right? All the solutions are given by, which is known as your general solutions, by that addition on the right hand side. The same thing applies for cos. I can add 360 and I'll get exactly the same. If I add 360, I'm just going to revolution, just doing a revolution. So I end up, if I add 360, I just add basically, it's a repetition, right? And I can add 360 over here. It'll also be k is some integer that I'm creating out of nowhere, and that's again your general solution, right? General solution. The general solution for arc10 is repeating itself every 180, right? It's repeating itself every 180. So this one will be plus 180 degrees k. K is an element of integers. Now you can also write this in radians. So with radians, we just simply replace this with pi, replace that with 2 pi, replace that with 2 pi, wherever accordingly, etc. Those are the way we would solve. And when we say we are solving trig functions, we are basically trying to find the angle. But for sine and cos, we end up with two solutions. We end up with two solutions, and we also end up with general solutions for all of them. Whereas for tan, it's simply one solution that solves it all. Okay, let's look at an example. Let's suppose I got y equals, I don't know, let's say we want to try and solve for theta. Let's say a half is equal to sine theta. If I want to find theta, I would move sine over and shift sine it on the other side. When I put that on a calculator, shift sine of 0.5 will be 30 degrees. I'm using degrees over here, right? So that means the second solution, that's the first solution, the second solution would be 180 minus that, which is 150 degrees. So for sine, you can either have theta or 180 minus theta. Sometimes they give you restrictions on theta. They say theta has to be between 0 and, or it has to be between negative, I don't know, let's say 200 and 300. I don't know. And you can provide all the solutions that exist in there by plus and minusing 360. So if I plus k 360 on each of these, I can get repeated solutions across a certain domain that gets asked for me to find it for. All right, apply the same principle with cos, but I remember with cos theta equals to half, you can either have theta or negative theta as your solution. And for tan, theta equals to half, I will just have one solution, theta. Again, the general solution will apply over here, and I can do exactly the same thing. So theta equals cos half, find the angle, that'll be theta 1, and then just put a negative in front of it to get the second one, because of how the cos graph is also designed or created from the triangle, right? All of this starts off from a triangle. So negative 60. And symmetry on the graph shows it quite clearly. Then you go shift tan for a half. So theta is equal to shift tan half. And that's equal to 26.6 degrees. One solution there. We plus k 180. K is an element of the integers. We can also plus k. If we need it to fit in a certain domain, we could add 360 for these two until we have exhausted all the possibilities between that interval. And likewise, plus or minus, not just plus, so plus or minus. I should put plus or minus there, k3, because you can go either way, left or right. And then we end up with functions that are like trig, completely something you need to solve. So let's say you got 1 over 3 equals 5 sine 3 theta minus 40 degrees. I don't know, something like that, right? Now you want to solve for theta. So theta, you gotta use equations. So we divide by 5 to get 1 over 15. We then arc sine it. We end up with 3 theta minus 40 on the left-hand side. And once we end up with this solution over here, arc sine of 1 over 15, for example, is going to be 3.8 degrees. It's a very small number. 3.8 degrees angle is going to be the size of this whole thing, right? At this juncture, you stop and you realize that there is another solution, which is 180 minus 3.8, and that is 180 minus 3.8 is 176.2 degrees, which will get you 3 theta minus 40 degrees. And now that you've got that, which you've applied by the rule, you would then only distribute everything else in. So now you divide this by 3 and plus 40 to get theta. You divide this by 3 and plus 40 to get theta. So 3.8 divided by 3 plus 40 comes to 41.27. And 176.2 divided by 3 plus 40 Comes to 98.73. But now remember, when you added K360, you added it over here. So you would do the same thing here. Actually, the other side would be over here, because that's where the angle is. Which means that for the 360, you also have to divide it by 3, right? Also have to divide it by 3, which means that your final answer will plus K120. Plus K120, because there's been some kind of transformation. Right, K times 120 or 120K, if you want to call it that, right? 120K or, all right, I put it the other way around there. So that's an idea of how you would have to stop. The moment you move sine over, you stop and you get two answers. Get two solutions first before you move the rest over. And you keep those two, then move. That makes sense, right? All right, you want to try one? Oh, I think we just ran out of time there. So what I'll do is